Good morning. So I'm going to talk about extreme programming. Some of you may remember. I'm going to talk about the way that extreme programming won and what we may have lost along the way and what to do about it. So first, by way of introduction and the topic, a little bit of history. Back when I was a extreme programming, then agile, then whatever, trainer, consultant, I used to start engagements by asking people when they thought the first extreme programming project took place. The project, the first named extreme programming project, became visible to the world in 1996. Had been running for a while before then. So yeah, 94, 95, 96, you're looking at the right sort of era. What was the business domain that they were addressing? Another question that I would put to cohorts for trainees. Any offers? The correct answer is payroll for prize day. So you're in the manufacturing industry broadly, but in the finance operations part of that business. And that is interesting, I think, because again, when I put this question to kind of corporate training folks, they would tend to say, in line with the early 2000s timeline, they would say kind of .com web agency stuff. But the thing that I want to highlight about this is that they were doing business critical, back office, get it right or you are done, high commercial risk stuff. It's 1995, let's say, you're doing payroll for one of the largest manufacturing concerns in the United States, heavily unionized. If you mess that up, you are done. And there is a very clear and precise definition of what mess it up looks like. And that's the origin myth of extreme programming. It's not make it up as you go along. It's not seat in the pants, fly by night stuff. It's not web. Got a whole other talk about how web apps are the stupidest idea the industry has ever come up with. But was that the start of extreme programming? Well, we've had a few clues already that it wasn't really. That's when the name got attached to a published thing. But before that came a thing called Episodes, Part 1, which was published in 95. And it's a pattern language, an organizational behavioral pattern language. Therefore, it describes things that had been seen to happen in multiple instances in industry over the preceding few years. So it codifies things that were seen to be going on in a particular technical culture, actually Smalltalk technical culture mostly, over the, let's say, the first 5 years of the 1990s, and actually reaching further back. There is a good argument to be made that the tradition they were working in goes all the way back to very early stuff. But we don't. I don't need to go back that far. Episodes, like all good descriptions of practice should do, tells you the context in which it is expected to apply. And it says that it's a form of software development for an entrepreneurial organization. Well, this is the 90s. People are building software to put into products that users, customers will buy a license to use. Arguably, they don't buy the actual software, but they buy a license to use. It's not like the subscription model on a service that we're perhaps more used to these days. The product that I worked on at the time was distributed to users by installing it on a $10,000 Sun workstation and then shipping the workstation to the customer. They got to keep the workstation, which is But these were real products, and they competed in a marketplace, and the teams that worked on them were part of an entrepreneurial structure. So I've boiled that description of what episodes aims to address. That is the issue is here: software development for an entrepreneurial organization, a small team of bright and highly motivated people. Time to market is highly valued. Got to get something in the hands of the users quickly. Development dollars are in short supply. Don't have deep pockets behind us and we can fluff about with all sorts of random things. We place a high value in being able to get a second version out of the goal. It's something into the hands of users quickly, and then a second version, and then a third, and then a fourth, and then and on and on and on, for as long as our customer has desires. That's the context that episodes is trying to address. So it's entrepreneurial in the sense that we're in a competitive market. It's products we're going to sell, they're competing products with similar feature sets. We want to get something in the hands of users quickly, but we are also playing the long game. We plan to be in business selling incremental improvements to this product for a long time, for as long as there is demand. That's what episodes is all about. Hold that thought. Entrepreneurial organization. So episodes part 1, as was published, it's got this shopping list of stuff in it that teams might do. I'm not going to go through that in very much detail, but I'm going to call out a few things. It's about a team that organize themselves into work groups to take items that they might want to work on. They might split those. They do a work queue report to update their stakeholders about what's going on, what they can reasonably expect. They've got completion headroom that allows them to flex on what they do. They're not running up against sharp organizational constraints all the time, but now and again they might have to do a recommitment, which is described as public embarrassment. When you find that you're running out of headroom, your headroom is declining faster than you're happy with, and you might have to stop and replan, do a work split, think again. The thing I want to emphasize there is that it's all about decision-making under uncertainty. You don't know exactly what customers are going to value. You don't know exactly what you're going to be able to get done by a date for the money. You don't know exactly what solution is going to be best. You don't know exactly what's coming next. You need to make decisions about how to allocate your scarce resources in order to achieve the best return. What is the name for that school of thought?
Economics.
Economics. Thank you. Yes. Economics is about decision-making under uncertainty to allocate scarce resources amongst a bunch of options that you don't really understand in the hope of maximizing your return. So these entrepreneurial teams working in the episode's way, they are economic decision makers. Let's talk briefly about engineering. At the time that I first heard about this extreme programming stuff, I thought I was a software engineer. I had, after all, gone back to university as a postgraduate to pursue a master's degree in software engineering, which at the time was all about boxes and arrows and upside down A's and back to front E's and all that delicious stuff and state charts and yum, yum, yum. And I thought I knew what I was doing. Well, maybe, maybe not. Let's sneak up on the idea of what engineering is. I'm going to propose that philosophy has met its primary goals when we are wiser. We do some philosophy, and at the end of that, we are more wise than we were at the start. Other things may happen, but that's the primary goal of doing philosophy. That overlaps a lot with pure science. Pure science will also make us more wise, but in addition, we are also better informed about the actual stuff of the world and how it behaves. And that overlaps a lot with applied science, which will do those things as well. We might get a bit wiser, we will learn some more about the stuff in the world and how it behaves, but we will also get something useful. If we're going to meet the primary goal of applied science, we're going to get something useful, a technique or a material or an approach or something else that we can realize in a way that has utility. Then coming in from the other side is economics. decision-making under uncertainty, constrained resources, exploring options that we don't necessarily understand very well to try and maximize return. And I assert, I actually checked this with a former colleague who is a chartered engineer, so he should know that engineering, this is not a definition of engineering, but it is a true statement about engineering, that it sits to some degree in that overlap between applied science and economics. There's a little saying that people trot out from time to time. It says, an engineer is somebody who can do for a penny what any fool could do for a pound. Engineering is essentially economic. You take applied science and you deploy it in the world in a way that you can afford, and that is going to secure some return. Shorthand, I would say engineering is useful and profitable. If it's not profitable, you're not doing engineering. You might be drawing lots of boxes and arrows. If you're not making money from it, you're not really doing engineering. You're not saving money or protecting money or reducing risk or all those other things. But fundamentally, it's applied science and economics. So we'll come back to that. There was supposed to be an episodes part 2. Episodes part 1 talks about organizing a team, organizing work, planning, tracking, recognizing risk, what to do about it. Episodes part 2 was supposed to talk about technical practices that would make it viable for you to do that. And we know what was supposed to be in it because episodes part 1 has an appendix which contains the table of contents of the proposed write-up of episodes part 2. And it talks about things like pair programming. And remember, episodes is a pattern language. It's describing things that were already well established in a certain technical community in the years beforehand. So we're talking about people doing pair programming in the early 90s and before. It talks about having test fixtures in a test repository that you have some tool to let you browse amongst. It talks about spike solutions. It talks about literal stubs. It talks about architectural substitution and architectural spoofs and all this good stuff. And it was never published. In that form. What we got was something else. But before I tell you what we got, let's talk about refactoring. Another pop quiz, as the Americans call it. I'm not sure why. When was refactoring invented? It was talked about in detail in a respectable publication that you can point to, first in '92, in Opdyke's PhD thesis. But again, that's talking about a line of thought which had been developed for some time prior to that. And again, there are good arguments to make that it goes way back. But as a thing with a name described in a publication that you can point at, again, early 90s, summarizing work that was done in the years before that. And Opdyke says that his thesis defines a set of program restructuring operations that support the design, evolution, and reuse of object-oriented application frameworks. Reuse was a big deal at the time. People got terribly excited about reuse. It's proven to be a gigantic distraction, an enormous red herring. But in this case, it needs to be understood in the context of, once again, Smalltalk. Who's done some Smalltalk? An unusually erudite bunch here. Most people go, what? So the thing about Smalltalk is that the Smalltalk programmer spends their time sitting in front of, from the first minute of the project, they spend their time sitting in front of a working, tested, hardened, high-performance, robust, reliable working system called Smalltalk. Just happens to not do what they wanted to do. And then the act of programming in Smalltalk is to change that running production strength system while it is running into something that does do what you want. which is a bit headachy if what you're used to is writing a whole load of text in a file that you then throw at a compiler in the hopes that it will turn into a binary, in the hopes that when you deploy that into a runtime environment, in the hopes that it will end up doing what you want. So when Opdyke talks about refactoring, working on object-oriented frameworks, what it means is the vast mountain of stuff that you get with Smalltalk, which you then sort of massage and manipulate and transform to turn it into what you want, or what your customers want. Refactoring is goal-oriented. When I first started learning about this stuff, a common criticism of refactoring as an approach to designing systems was that you were doing a random walk through the possible configuration space of the solution, and it was going to take, therefore, basically an infinite amount of time to get anywhere useful. This is not true, because you're not doing a random walk. You're doing a directed walk. There is a vector field whose gradient you can look at to tell you where to go next. Might get caught in a local maximum. Watch out for that. So refactoring is, by definition, don't change the externally observable behavior of a program. So Fowler's definition of refactoring is improving the design of a working system without changing its external behavior. But this is what Opdyke says. Refactorings do not change the behavior of a program. They can support design and evolution by restructuring a program in the way that allows other changes to be made more easily. So when we're working in Smalltalk kind of style, the first thing you do is improve functionality to be closer to what you want. And then you improve the design. And the primary figure of merit for a refactoring is that the next change you need to make is easier. And so if you're going to make, if you set off to make the next change and it's looking like it's hard, then the thing to do is take a step back and do some more refactoring. So that then the next change you want to make in the interest of functionality will be easier. Top tip, by the way, to recognize whether or not you've done a good refactoring. If you've done a good refactoring, you will get to delete some code. You will remove duplication. And that's one of the premier reasons why refactoring makes code easier to change next time, because you've got less of it. Code is the enemy. You just want to cut that stuff out. Code is a bad thing. Every line of code you write is a liability. It's a millstone around your neck for the rest of your career. Just don't go there. Refactoring gives us a way to tame that. And this, again, is very natural to Smalltalk. It's what they do all the time. And they learned a habit of thought where you start with a full strength, industrial strength, hardened, deployable thing, and you turn it into what you want. And refactoring is the steps for getting it there. We'll come back a bit to that. So we didn't get episodes part 2 in the form that was expected. What we got was Extreme Programming. In fact, what we got was Extreme Programming Explained, first edition. And I checked with Ward Cunningham, who was the author of episodes part 1. I said, hey, Ward, it kind of looks like Extreme Programming Explained is the episodes part 2 that we never got. And he said, yeah, it is. The first cut of the book was episodes part 2, and then Kent took it on as a solo endeavor. So that's literally true. And again, there's a shopping list of practices, some technical, some organizational. And then in a while after that, about 5 years later, we got the second edition, which is green rather than white. You will hear people in Extreme Programming will talk about the white book and the pink book and the green book, which also they learned from Smalltalk, by the way. The original Smalltalk manuals came in a whole bunch of volumes that were different colors. What goes around comes around. So this is the second edition. And again, it talks about technical practices and it talks about organizational practices, and that slots in there. First edition, 2000. Again, summarizing what had been learned over the preceding 5 years or so about how to do this kind of stuff. 2005, things have moved on, people have learned more. And I'm going to say but around about that time, XP won. XP was fantastically controversial when it was first launched on the world. People like myself included looked at it and went, that's irresponsible, verging on professionally negligent. How could that possibly work? Well, the answer is very well. It's like people used to ask Liberace, how do you manage to play the piano with all those rings on your fingers? And say, very well. Rarely get to deploy a Liberace joke at a technical conference. XP1, I maintain, even though everybody pretty much stopped talking about it, if Google is to be believed, around about 2016. Nah, not really interested in XP anymore. Certainly don't ask Google about it. Scrum, yeah, interested in Scrum. Agile, interested in Agile. DevOps, copy thing. XP, nobody talks about it anymore. So if you were, as I was for a while, a coach or a consultant whose business is to teach people how to do XP or support them in learning how to do it better, well, we had to move on to other things. But I still maintain XP1. Kinda. Because a lot of the things that XP talked about that were controversial in 1996 and even were controversial in 2006 have become part of the background assumption about how you write software these days. Comprehensive suites of automated unit tests written early in the process are no longer controversial, but they were. Pair programming is broadly acceptable. And now we're moving on to more ensemble programming being broadly acceptable. Collective code ownership, maybe in a sort of Git open source style, but collective code ownership of a kind. Continuous integration, which again was controversial and almost unimaginably difficult in 1996. That product that I worked on that was shipped on the workstation, we integrated once a year. In those eyebrows, for sure. we integrated once a year. It took about 6 weeks, and at the end of it, people would quit. The idea of integrating multiple times a day blew people's minds. But now it's kind of expected that you be close to that, or at least going in that direction. Coding standards, understood by the whole team, enforced by tools. Yeah, that's uncontroversial. The informative workspace practice with dashboards and information radiators, again, controversial, verging on impossible. Back in the time, small releases, pinged out very often. User stories, kind of, and so on and so on. That's all just become part of the background assumption of how you're going to do software development in most of the industry, most places, most of the time these days. And yet, let's talk a bit about TDD, subject very close to my heart. Never was a named practice, not in the white book, not in the green book. Episode part 2 in its shopping list of stuff has test suite repository. So there's enough test suites around that you need the tool to manage them for you. And there's a test suite browser that lets you navigate through it and understand what's going on. And there are test fixtures that let you repeat tests again and again and again. And there are literal stubs that make it easier to write a test because they short circuit evaluations, pre-cooked results. TDD is not quite there. The white book has testing as a thing that developers are expected to do. And it's kind of assumed that it will be automated testing, but TDD is not there. And the second edition has test first, but TDD itself is not named. However, it was talked about in an article published on as a blog post, and it comes on the old JUnit website. It was published in 1998. It took a while for people to really figure out what test Testing, automated testing, lots of it early first driven. Took a while to figure out what that really does. So it was there from very early on, but it was, they were a bit shy about it. Some people say that like it wasn't talked about very much because it was a bit too scary still. It was like really controversial and people really rebelled strongly against it. So like, soft pedal, but it was always there. This is the TDD cycle with which I'm sure most people here are very familiar. Add a test, singular, see it fail, always. Make it pass and implicitly keep all the rest of your tests passing as well, and refactor, mandatory step, built into the process. Improve the design. Enhance the functionality, demonstrate that you haven't broken anything in regression, improve the design. Right there, not in the hardening sprint in 6 months' time, not in your Friday afternoon technical wash-up SOP that the project manager has graciously deigned to allow you. Right there. Going around this cycle should take a few minutes every time. So at the top, when we add a test, that's where we add capability, or we announce our intention to extend the capability of the system to do more of what we want it to do, or more of what our customers or users need it to do. And the refactor side is where you improve quality. Largely in the interest of making the next test easy to write. And that means you can go fast safely, which is what they thought the point of it was to begin with. We can go really fast and we can be confident we didn't break anything along the way. We do not bring the project to a halt for 6 weeks while we do design, but not even 6 days. 6 minutes, maybe. 6 hours. This means it turned out that what it meant was that you explored the problem domain in terms of examples, because the thing that's in a test, in a TDD test supported by the fixture, is a concrete checked example of what you want the system to do next. And those examples guide your exploration of the solution space in the refactoring step. So you end up with suggestions for where to look next. The code will tell you where to look next for an interesting example of further functionality you want to add, and then you refactor to keep the implementation clean and easy to change and easy to extend, minute by minute, hour by hour, day by day, all the time. So you end up with growing object-oriented software guided by tests, which was published in 2009, and is a extended illustration of how that works. Took that long for the community to really figure out what test-driven development was really doing. One of the authors of Goose, as it's known, Growing Object-Oriented Software Guided by Tests, is Imo and I's former and indeed current colleague, Steve Freeman. All praise to him for doing the work on that. And we kind of lost that. This is one of the things we lost. People do still sort of talk about doing TDD, but maybe what they mean really is test first. This idea of exploring the requirement or the need through examples and then doing design through refactoring, fine-grained, compulsory step, minute by minute, hour by hour, we've kind of lost that. That's a shame. I remain convinced that it's faster and lower risk and cheaper in the long run than the thing that people tend to do, which is to think up a design, write 100 tests which assert that my design idea will be present in the system, and then try to make those 100 tests pass, which just leads you back into, spend a month debugging at the end of that. Catastrophic. It has proven to be difficult to demonstrate those advantages, I will admit. But it's the right kind of way to think about how to justify a technical practice. Not in terms of shininess, not in terms of some exalted idea of software personhoodliness, not in terms of pleasing some prophet of design excellence, but in terms of going faster at lower risk so you can better serve the needs of your customers and get back into that intersection of utility and money, applied science and economics. But we lost, we pretty much lost the argument on that. Teams. So episodes and Extreme Program, they talk about teams and they talk about roles, not people. So it's not heads. It's not hands on keyboards. It's roles that a team must have in it to be successful, being with the chance of success, I should say. First edition, the White Book talks about programmers, which is anybody who has their hands on the technical artifacts of the system. The customer, singular, just the one. Testers, who are really developers. And then some supporting roles, a tracker who keeps an eye on that headroom and monitors risk and so on, a coach who helps the team maintain the discipline that they have said they want to follow, consultants that you might hire as point solution specialists for some particular skill that you don't have in the team, and a big boss who is going to clear the ground for you, clear the way, provide what has regrettably in many organizations called air cover, so that you can get on and do this stuff without having people pinging in from the, you don't want the senior executive vice president of Boxes and Arrows pitching up and telling you you're doing it wrong.
Now, question.
Yes.
What do you mean by customer singular?
What I mean by customer singular is that there is one person to whom you can go to obtain a normative decision about what you should do next.
So in that sense, it's a role and a person.
It has, so in the early projects, it was a person. Turned out to be almost impossibly difficult for one person to do it. And bad things happen when you put one person in the chair, but the role certainly is singular. There has to be somewhere you can go to get exactly one normative, I say normative, not correct, but normative decision about what you're going to say. Well, we could do this and then this, or then this, and which is it? And somebody needs to say it's that one. And you run with that, and then you find out later whether they were right or not. And the second edition talks about programmers, again, anybody who's got their hands on technical artifacts. Architects who do architecture through refactoring. They don't get to draw boxes and arrows. They get to sit down with the team, fingers on the keyboard and say, not like that, like this. And maybe they get to spend a couple of days doing a lot of restructuring rather than a few minutes every time on the cycle. We have users, plural, real users, actual for real users, the people who are going to get the economic benefit of using the features that you build. Testers, again, a role that developers do. Interaction designers, because in the 5 years between the two editions of the book, Extreme Programming has moved out of that kind of back office finance world into the world of software that normal people might expect to use and get some value for. And they're not going to put up with the kind of stuff that back office finance people are going to put up with. Technical writers, a role that's more or less disappeared, but people who are good at explaining and good at asking the questions that normal people are going to want to ask about your system. Facilitated by. And HR was added to the list there. We need somebody to look after the people stuff. Programmers do small refactoring often. Architects do big refactorings less often. Nobody is drawing boxes and arrows in this world. It's all about the code all the time. Product managers, users, testers, interaction designers, and technical writers help to write and pick stories. But it's the product manager or the customer in the old world, the product manager in the new world, who makes the sequencing decisions, that and then that, or that and then that. And they do that strictly on business value. Strictly. The question is always, what is the next most valuable thing for us to do, we think? We'll confirm by testing in the market, but not technical sequencing and blah, blah, blah. No, what is the entrepreneurial? Remember, the team is an entrepreneurial team. Its North Star, as they call it these days, is making money. And then the project managers and all these other supporting roles kind of make it possible for you to do that. Secure budgets, agree contracts, all that sort of jazz. But also provide an overarching vision and direction for what the endeavor is about. Customers and users. Yeah, no, we don't get that anymore. These are people with a direct connection to utility and value, and they are part of the team. You don't go and consult them from time to time. You certainly don't hear from a business in extreme programming. You don't hear from a business analyst who was given a briefing by a product manager, who was given a briefing by an executive VP of product, who was given a briefing by the boss of the users, all of them speculating wildly about what might turn out to be useful. No, you have 4 real users, or if you're in a more of a sales mode, 4 real customers in your team. They are part of the team. We've pretty much lost that in the industry at large. And all of these people helping to write and pick user stories, but having a very clear economic decision maker in the team who's making decisions about sequencing based on business value, we've pretty much lost that as well. Let's talk briefly about user stories. Episodes talks about the implied requirement. So you name something, so you've got something to talk about. We're going to talk about the parameting the fubula this month, so everybody knows what you're talking about, but you don't write down acres and acres of requirement for that. Allow the names to imply requirements without actually enumerating requirements in the traditional sense. And the traditional sense was a honking great document. Some of you here, I'm sure, were familiar with the kind of thing, several hundred pages of dense text telling you exactly what you have to do. No, none of that. We came to say that a user story was a token for a conversation about the requirements. It wasn't the requirement. It was a token that let you go and talk to some people about what the customers and users in your team. You're going to talk to them about what it really meant. In the second edition, we talk about stories, the units of customer visible functionality, being the thing you do planning in terms of, not technical tasks, useful stuff that's visible to the users. That's what you plan and track in terms of, and you get everyone in the team thinking about how to get the greatest return for the smallest investment. Entrepreneurial thinking, economic thinking by everyone in the team, including the engineers. They are not just munching down a list of to-dos as quickly as possible. They are part of an entrepreneurial organization that's making economic decisions. A whole team activity. Stories stand for ways to perhaps add value. They're the unit of scheduling, not technical tasks. And that's pretty much gone completely out of it. Agile teams these days, far too often, not always, but far too often, they're given a list of technical to-dos to do to, and off they go. Missed opportunity. So XP itself, like episodes, is a pattern language. The practices all work together, they reinforce each other. The more of them you do, the easier it is to do more of them and do them more. So, for example, collective code ownership. If you have collective code ownership, it's easier to maintain your agreed coding standard, even if you don't have tools to enforce it, or there are things in it that tools can't enforce. And that makes it easier to do continuous integration. And that makes it easier to maintain simple design by refactoring. And that makes it easier to do pair programming because people can drop in and out and they understand what's going on. And that makes it easier to maintain collective code ownership, which, and on and on and on we go. There are all these virtuous feedback loops amongst these practices. They reinforce each other. The more of it you do, the easier it is to do more of it and to do it more. And we've kind of lost that. Teams these days, they get handed a fairly random bag of practices, possibly culled from a giant wall chart published by a consultancy, and they're told to get on with it, missing a trick. So back to this question of engineering software. To really engineer software, to be at that intersection of applied science and economics, I think XP is one, not uniquely so, but it's one of the things that inhabits that intersection. I came to realize, I think, believe, came to the professional opinion that if you want to really and truly engineer software, like you were a software engineer, then extreme programming is one way to do that, much more so than the boxes and arrows and upside down A's and background E's that I was told, even though those things have a place, but they're not the essence. So I think XP and things like it, but XP is like the example, take software seriously as an engineering material. And the practices in there, which emerged out of industrial experience over decades, and summarized in these publications over about 15 years, based on real people, very smart people's real experience of really building software to really meet the economic needs of real users in real industry, rather than speculation and consultancies or academia about how you might do that, in terms of what is easy and what is hard with software as it really is. And XP is a toolkit, a pattern language, and a way of behaving that takes advantages of the strengths of software as an engineering material and mitigates its weaknesses as an engineering material. But that's for real engineering, I think, pretty sure. So back to that idea of being entrepreneurial. An episodes team, an XP team is entrepreneurial. The whole team is entrepreneurial. It's not that there's a product owner or a product manager who's maybe part of an entrepreneurial organization. The whole team is entrepreneurial. And the XP practices exist to support that. And that's kind of gone out the window as well. What we've got is this sort of hedge scrum, hedge agile, folk agile, where you've got a feature factory whose job is to bang down an unordered, unbounded list of tickets. And the figure of merit is how fast you bang through your tickets. There might even be a graph showing how much more quickly these days you ship tickets than you did before. And we'll call that success. You need to beg for time to refactor. No, none of that. Tickets, functions, features, get it done. What are you talking about? Refactor? Did you not get it right first time? Give you a whole other hour about technical debt and how badly it's been misunderstood. So, but at least nothing gets written down. Like back in '96, they were saying, well, we don't need to write lots of stuff down. We can have conversations and produce working artifacts on it. Oh, we don't write anything down. Brilliant. Okay, let's cobble that out. And then we'll say that we're doing extreme programming. And these days we are agile, so we don't write it down. That's the point. That's the least interesting bit. So what can we do about this? So a lot of the stuff is baked into our world now. Some of it has been superseded over the last 20 years. If you look at the white book, you look at the green book, there's way too much in there about estimation. which 20 years ago seemed like it was really important. We have learned since then that, yeah, maybe not so much, a little bit, but not as much as they used to talk about. But I think there's an underlying principle that we can all seek to recover by just in our workplaces demanding to do it, which is to be part of a team which develops software-intensive products and services in an entrepreneurial setting. The whole team, entrepreneurial, not part of an organization that's got a department of entrepreneurs who are going to tell you what they want from time to time. And XP still provides a language for doing that. Provides a way to talk about economic justifications for technical practices, which we should learn to deploy. There are lots and lots of technical reasons why refactoring is a good thing. Project manager is not going to be interested in any of those, but if you can make an economic argument for it, you might get the attention of some executives who will back you up. Pair programming, there are economic arguments for doing it. Technical ones as well, but economic arguments for doing it. Or perhaps TDD with that refactoring loop built in. That one's a bit harder, but for me. Or whatever. Learn the economic language for justifying these things, not just the technical language. And interrogate the economic justification for things that the team is asked to do. Here are the next 2,000 tickets we want you to bang through. Like, why? How is that going to help? What money is that going to earn or protect or risk is it going to defray? I'm not going to change the color of that button on that website unless you tell me why that's economically beneficial to the organization to do. You mean it isn't? Gosh. You mean I'm fired? No. So, as I said, XP is one way to engineer software. There are others, but I really like XP. Be entrepreneurial. Know the economic justification for what you want to do and interrogate the economic justification for what you're asked to do.